In earlier video, we have discussed about simple microscope and compound microscope to see the smaller faint objects clearly, means magnifying size. Now we are going to discuss about telescope. Telescope means it's a device or it's an instrument which is used to see the heavenly objects, means distant objects clearly in magnified, clearly and magnified. Here is the two types of telescopes we can be seen. There are two types. In that one, the first one is astronomical telescope. Astronomical telescope means the instrument which is used to observe the heavenly objects are like moon, stars, planets, etc. distant objects we can see, we can observe the distant objects. And also the image is formed by using the astronomical telescope is a inverted image, and it's a virtual image. So here that it is consists of what is meant by, first of all, astronomical telescope, a telescope which is used to see the distant objects like moon, stars, planets, and the image is formed, it's a virtual and inverted image by using the astronomical telescope. In that astronomical telescope, it consists of two lenses, means two converging lenses of objective lens. This one, the object side of lens is called as a objective lens, and the eye side of a lens is called as a eye lens or a eyepiece. In that case, there is a far object is there, the distant object, far object is there. When the light is incident on the first objective eyepiece and it is refracted, one light is moving in center and another one is it, whenever the total object is focused on the objective piece, then the inverted image is formed. Means here the objective piece or objective lens is having the more focal length up to 50 centimeter to the 100 centimeter. So here the objective lens of large aperture or a focal length of 50 or 100 centimeter. This is the objective lens has having. This is the focal length of FO is 50 to 100 centimeters, and in the eyepiece side of a piece is having the least less 2 to 5 centimeters of focal length or aperture is having. So here is that by it consists of a two lenses, and these two are fitted in the cylindrical tube. One is moved on another, which is slides on another. Means whenever these two are the one is moved on one another. So that's why here these two are fitted in the cylindrical tube. So from this case, when the light is incident on the eyepiece, then an erect and image is formed, inverted image is formed. Image is formed at A1 and B1. This with the real and inverted image is formed invertedly. So which is making an angle is alpha with the visual angle. Visual angle means the image is formed, that is alpha, means object visual angle is alpha. So here is that we are taking that. Then here when the object is inverted image, this image is acts as a object for the second lens. So here is that from this one, whenever the image is incident on this like a object at a distance of UE, then it will form the distant object at far distance at VE be the A2 B2 be the virtual image, and inverted image is formed finally. It means this is the final image, it's a inverted image which can be formed at a distant object. So this is about astronomical telescope. By the calculation, now we are going to let us see about the how do we calculate the magnified image. What is the magnification will depends on the distance between, if the object is at a distant and a near point. Whenever the image is formed at near point or a distant object, then we will derive the formula for the astronomical telescope. Magnification means angular magnification. So when considering AB is the object at a distance of AB. Consider distance distinct object AB, and its real and inverted image is formed, that is A1 B1, and the image becomes this image becomes objective for the second lens. So that's why we are writing that angular magnification of a telescope, m is denoted with magnification. So here is that angle subtended by image that is beta, means this is the angle subtended by the image that is beta, and total, from the total diagram we are taking that, and here by angle subtended by object with an eye, means by taking this, whenever the eye is placed near to the lens, then this will be the angle subtended by the angle that is alpha, and if is this alpha, then this is also alpha, because of this ray is moving from the center of the lens. So that's why without any deviation, without any refraction, that is moving along a straight line and forms the image at a distance A1 B1. So here is that if this is alpha and this angle is also alpha. So here it is that from figure, this is alpha, that is equal to beta by alpha be the angle. From figure we can write that m is equal to beta by alpha. From that m is equal to, we know that beta means it's a tangential thing, so that's why we are taking that here, that is beta angle subtended by this is the beta angle. So that's why tan beta is equal to, this is opposite by adjacent. Opposite means that is A1 B1, that is magnified in the inverted image. So that's why we are taking that according to the sign convention, whenever the lower side means below the principal axis taken as a negative, so that is minus A1 B1 by, this is the distance from object to the optical center to the image is formed, means whenever from the distant object, that is UE. So that is taken minus UE, because of we are taking opposite direction to the incident ray. So by, again if we are taking that the angle subtended by object with an eye, means this is the angle alpha, whenever we taking this is also inverted, so that's why we are taking that A1 B1 minus A1 B1 by, here is that the object is alpha means adjacent, the distance from optical center to this one is F0 in the direction of the incident ray taking, we are, so that's why there is positive F0. So here is that by taking the values of, we can get minus F0 by UE, because of minus get cancelled, A1 by 1 get cancelled, this FO is denominator for the denominator, so it will becomes a numerator and UE becomes a denominator. So that's why minus FO by UE, that is equal to total magnification FE is equal to so here is that magnification M is equal to F0 by UE minus F0 by UE minus. From the figure means whenever by taking that the eyepiece, only we are taking about the eyepiece, whenever we take the eyepiece, then from the lens formula we can get the values for something. So according to this eyepiece, that is for eyepiece, the object means this image will be acts as a object for the lens. So that's why we take that the distance of image is minus u is equal to minus ue, and image is also formed at a distance of ve, the final infinity image due to the second lens. If we see from this is our eye, whenever we watch this, then the image is formed at a distance of v, the infinity final image is formed at a distance of v in the direction of opposite direction. So that's why v is equal to minus ve and focal length f is equal to fe. So here is that when the Fe means it's a converging lens, so that's why focal length will be positive. So here is that by from lens formula we have that 1 by V minus 1 by U is equal to 1 by F. By substituting this formula, the value substituting in this formula, we can get this 1 by minus VE and 1 by minus VE minus 1 by minus UE is equal to 1 by Fe, 1 by Fe. Then minus into minus plus, this will minus becomes minus. Whenever that 1 by minus we take into this side, this will become minus UE plus UE because of minus into minus plus. So that's why plus UE is equal to minus 1 by VE is taken to this side, then it will becomes plus 1 by Fe plus 1 by VE. From this we can write that 1 by UE is equal to, by taking common 1 by Fe taken outside, then it will becomes 1 plus by Fe by V. Fe by V means 1 by VUE is equal to 1 by Fe into, by multiplying 1 by Fe inside, then we can get that 1 by Fe plus 1 by VE like this. Again same formula we can get by multiplying inside, then 1 by UE is equal to 1 by Fe of 1 by plus E 1 by Fe with the equation whenever for the image whenever. Then there is a two possible adjustments is there for this formula, for two possible adjustments when the image is formed at the near point and image is formed at a far point, means infinity, means whenever the image is formed, when final image is formed at near point, final image formed at a near point, near point means that is a velocity VE is equal to certain distance d. By substituting this one, then the capital M magnification M is equal to, by substituting in this formula, then we can get M is equal to means the magnification, here we have that M is equal to minus FO by UE. So minus FO by UE means we have the formula, this one 1 by UE is equal to 1 by Fe into 1 by plus 1 plus Fe by V. Substituting this one, FO by Fe of 1 plus Fe by V is equal to D. So this is the formula when the image, final image is formed at a near point. Near point means whenever the eye taken to the near to the lens, then the distance of object which is equal to object distance will equal to D, means in case of whenever if the distance from the object is infinity, if the image is infinity, object must be placed at focus from the information of image. Already we have discussed about that in that previous formation of a lens, formation of a image by refraction. By in the concept we discussed about that when the object is at infinity, image will be formed at a focus, or if the image is formed at infinity, object is placed at focus. Then if the object is at infinity, the image will be formed at a focus. Like this, here if in case of that is Fe is equal to UE is equal to Fe, we can write that because of whenever the image is formed at a near point, means at a infinity distance, object is at a, object will be at a infinity. Infinity means UE is equal to infinity, it will become 0. Then also if in case of UE is equal to Fe, we can write that whenever the image is at infinity. Then let's see, final image formed at infinity. Final image formed at infinity. Formed at infinity. And one more thing, the distance whenever the final image is formed at a near point, then the distance between the two lens, the which is having the telescope, two lens, eyepiece and object piece, the distance between the two lens will be distance, the distance taken as L, the distance taken as L, this is F naught plus mod UE, means the value must be taken positive. So this is the distance for between the lens the distance between the lens whenever the image is formed at a near point, final image is formed at a near point. If we take that final image formed at infinity, then that is formed whenever the infinity is formed, the distance of object UE is equal to, it will become FE. UE is equal to FE, means here when the image is formed at infinity, must be object is placed at a focus. So that's why the distance of the object will be UE is equal to FE. Then the magnification M is equal to minus FO by FE, minus FO by FE from the equation. Minus FO by UE is equal to FE, because of when the image is at infinity, then object must be placed at a focus. So that's why here the whenever the object is placed at focus, then only image can be formed at infinity. Like this, M is equal to minus FO by UE is equal to FE. We are substituting minus FO by FE. Then whenever the two lenses are at a distance apart, means whenever the image is formed at infinity, the distance between the two lenses will be L is equal to F naught plus FE. L is equal to F naught plus FE. This is a distance between lens. Distance between a lens. This is about the image formation at a infinity and image formed at a near point by the using the astronomical telescope. Once again, astronomical telescope is an instrument which is used to see the heavenly objects like moon, stars, planets. Like that, it consists of two lenses. Two bilens means objective lens and eye lens are called eyepiece, which is objective lens is having more focal length or aperture, which is up to 50 centimeters to 100 centimeters, and the eyepiece is having 2 to 5 centimeters. And whenever the AB is be the object at a far distance, means by seeing the diagram, by watching the diagram, we can see that whenever the AB is the far object is placed, and whenever the when the light is incident on the rays in the object piece, then the image, real and inverted image formed at A1 B1, which is the visual angle of alpha. And also here the image A1 B1 acts as a object for the second lens, that eye lens, and final image is formed at distance of VE. Then from that, the magnification of formula we can derive from the equation, that is magnification, angular magnification M is equal to angle subtended by image beta by angle subtended by object with an eye is alpha. So from that equation, from the diagram, we can write that M is equal to beta by alpha, that is M is equal to beta means the angle subtended by the image, that is beta, that is beta is equal to its tangent, so that's why A1 B1 is inverted. Whenever according to the sign convention, A1 B1 can be written whenever the below the principal axis can be taken as negative. So that's why minus A1 B1 as taken negative by the image is formed because of this is the object for the second lens. So that's why the object is at distance of UE. This is also taken as a opposite direction to the incident ray. So that's why we are taking that here, that is a minus UE. And according to the whenever the angle made by the angle subtended by the object with an eye, whenever we watch the near to the lens, then the angle subtended by the lens, that is alpha, that is means alpha. So this is alpha is the angle, visual angle subtended by an eye with the object. So here it is, this is also alpha. Then from this formula also this is inverted. So that's why we are taking that minus A1 B1 by the distance in the direction of the incident ray. So that's why FO means F of focal length of object. Then minus F naught by UE, by cancelling both, then we can get that minus F naught by UE. That will be the equation for the angular magnification for the lens. For the eyepiece, if we take that the incident means U is equal to minus UE. Minus UE means the angle subtended by, whenever we taking that, this is the opposite direction to the incident ray, that is, so that's why minus UE taken. So here it is that U is equal to minus UE, and image is also formed in the direction of opposite to the incident ray. So that's why that is V is equal to minus E, means image is also formed in the direction of inside in the side of object. So that's why we are taking that opposite sign, minus. We are taking the converging lens is there. So that's why F is equal to focal length FE. positive Fe plus Fe. By substituting these values in the lens formula, that is 1 by V minus 1 by U is equal to 1 by F, that is minus 1 by V minus Ve minus into minus plus 1 by minus Ue is equal to 1 by Fe. Minus into minus plus, here is a plus, then minus Ve taken to this side, 1 by minus E taken to this side, it will becomes plus. So 1 by Ue is equal to 1 by Fe taken as common, so that's why it will becomes 1 by Fe is equal to 1 plus Fe by Ve. From that formula, if the final image is formed at the near point, then Ve becomes at a certain distance d. At a distance of d, near point, d means a distinct division. D means a distinct division. At the distinct division, if whenever the eye is taken to the near to the eyepiece, then it will become the image can be distance image can be equal to the distant vision, distant object. So that's why m is equal to, we have that m is equal to minus f naught by ue. The magnification formula means how much the image is magnified. So minus f naught by ue, we know that 1 by ue value we have that. So by substituting the values we can get minus f naught by ue means 1 by fe of 1 plus fe by d. D means a distant division. V is equal to we substituted d. Then whenever both are at a certain distance, lenses must be certain distance between the lenses. So that's why the distance of the lens will be L is equal to f naught plus ue mod ue. In that case we should take the value for plus, means mod ue means the image distance can be taken as a plus, the distance between the both. Then final image formed at infinity. If the image is formed at infinity by using the astronomical telescope, then here ue is equal to fe, means by whenever the object is at focus, then only the image can be formed at infinity. By the image is formed by the refraction. Already we discussed in earlier videos. So ue is equal to fe. So that's why m is equal to minus f naught by fe. So from the magnification formula, the distance between the two lenses will be L is equal to f naught plus Fe, the distance between the two lenses. This is about astronomical telescope. Next we are going to know about the terrestrial telescope. The image is formed inverted, as well as the image is inverted is formed. It is not useful for an object which is on the ground. Means whenever we are watching the cricket, another thing the border the erect images we can't see by using the astronomical telescope. So that's why another some of the lens means erectile lens or auxiliary lens which is used between the two lenses, object and eyepiece lens, between the both some of the auxiliary lens called or erecting lens which is used between the two objective and eye lenses. This is the lens is called erect or auxiliary lens, So here it is that by this using this telescope we can get the erected image. So that's why here to get the total erect image, it consists of two rectangular erect lens or auxiliary lens is fitted between the two objective and eyepiece. By adjusting this erected image, we can be formed. Means by adjusting this auxiliary or erecting lens, by adjusting this one, the magnification plus 1 image can be formed by adjusting this erectile lens. So here it is that the magnification of the astronomical telescope formula also used for this the terrestrial telescope also. From that formula we know that whenever the magnification means angle subtended by, here is also which is objective lens, we can get the alpha, and also whenever it is formed the image, then from that image also we can form that. Here is that from this equation, this is the one of the lens, we can get that. From this also we can get the magnification, means angle subtended by the image and angle subtended by the angle. From that image also, whenever the object is far object in the side of the object lens and light incident on the lens, and due to that and A1 B1 image is formed. From that lens again between the auxiliary lens, means erecting lens is between this. By adjusting this one we can get the another rays or refracted through the lens and incident on the eyepiece, and due to that eyepiece the magnified +1 means and the +1 image magnified image which can be formed means which is magnified in the above the principal axis means magnified image +1 image is formed above the principal axis. By using the terrestrial telescope we can watch the cricket match like this to see the erect image. To see the erect image it can be formed. So that's why here is also as well as a astronomical telescope we can do the two adjustment by using this lens, that is final image is near point. We know that the formula of magnification is m is equal to minus f naught by ue. From this formula we can get that here is that this is the focus f4 means the final point where the image is formed. So that's why we are taking that. Again the 2f and from the lens the distance is the double of its focal length means is nothing but radius, and this is also another radius which is having the equal radius, and also here is the image is formed at this point. This image will behave the object for the eyepiece lens. So eyepiece lens, object for the eyepiece lens. So that's why from this formula we can get that the near point means if in case of the object image is formed is near the image, then only v is equal to d. The near point will be the distinct vision distinct. So that's why v is equal to d. Then m we are substituting that. From the formula we can get that the distance between the two lens. The distance between the two lens will be focal of the object and 4f plus ue means the image is formed before the eyepiece. That is the length of the lens between the two lens whenever the image is formed, erected image is formed near point. Then if in case of image is formed at infinity, if the infinity formed, we know that the object must be whenever it is at focus, then only the image is formed at infinity by using the lens. Then m is equal to f naught by f, l is equal to f naught plus 4f plus 4e. This is the distance between the two lenses, object piece and at the same time eyepiece. This is the lens. This is about a terrestrial telescope. And one more thing is some of the another telescope is also there, that is Galileo telescope. Galileo telescope is also there, and also that is the first telescope which is made by the Galileo. So that Galileo telescope which is using this as a astronomical